Alright, so tonight we're going to do lesson 105, and we're doing symmetry and transformations. Now we've done some of this earlier this year, but it's really just another good way to practice. So in this lesson we're going to look for lines of symmetry. Figures that can be divided into mirror images by at least one line of symmetry are said to have reflective symmetry. If a mirror is placed upright along a line of symmetry, the reflection in the mirror appears to complete the figure. So if we were, for example, this one, to draw a line of symmetry, we could draw it right down the middle. And that line right there, we could put a mirror and it would show the exact same thing on each side, right down the middle. A line of symmetry divides a figure into mirror images. In each of these figures, a line of symmetry passes through a vertex and splits the opposite side into two segments of equal length. Here's our vertex right here, and these two sides are equal length. So I'm just going to draw my hash lines of equal length. We can also do it for our polygon here. Cut it right down the middle, and you can see our vertex is right here, equal length, equal length. So again, you can split it. Since these polygons are regular, we find a line of symmetry through each vertex of a polygon. Okay, so here's another vertex when your two lines meet. So we can find a line of symmetry going through this vertex, so a line right here, then also this vertex going over here. And on this polygon too, we're going to have a lot. Here's a vertex, a vertex, a vertex, and a vertex. So we have lines going through each of these that would also be a line of symmetry. You could draw it if you want. This one's going to come through here. This one's going to come through here. This one's going to go up through here. And then this one up through here. Okay, so they have a bunch of lines that would make them of symmetry. And you put a mirror right in between them, and you could see them both on each side. So what we're going to do now is look at the next two shapes. Here we show a regular quadrilateral and a regular hexagon. Find the number of lines of symmetry in each figure. Okay, remember what I just said. We were looking at the number of vertices that we had, or looking at a vertex. That's what the line goes through. So, if we look here, how many vertices do we see in this shape? And we would say 4. So 1, 2, 3, 4. So we can go ahead and draw. Here's 1, here's 2, here's 3, and here's 4. Okay, and the next one, there are 6 lines of symmetry for this. So we can draw 1, 2, okay, then we draw 3, and then we can draw 4, and we can draw 5, and then 6. There are 6 lines of symmetry there. So you're really counting the amount of vertices that you see, and then you're finding the line of symmetry through that. Alright, go ahead and write this down. Rotational symmetry. This is kind of like the next concept. Rotational symmetry regains original orientation more than once during a full turn. So basically what that means is when you turn the shape, it's going to look the same at least once during a full turn. So if I were to turn this shape, show you over here, and take this shape and turn it, it would look like this. Okay, and then this would be C if I'm moving this up. This would be C, this would be A, and this would be B. And then one more turn. We're moving this way, by the way. This way. And then I would be back to kind of my full shape. And this C would be up top now. Then I would have A over here, and B would have here. So this shape has rotational symmetry because if it's turned once, you're going to have at least one way that it looks the same as it was when it started. Okay, now we're going to do this next one, and it says which of these letters has rotational symmetry, meaning as you turned it all the way around, at least one time, it would be back to its normal shape. Go ahead and try to do it. You could write it and do it out that way, like an M would look like this, look like this, and then finally back. So this does not A, that would not work. T, not work. H, oh, if we look at the H, it's exactly the same. So this H would have rotational symmetry. Alright, and for your lesson practice, you just have 3 shapes. Now I tried to draw the last one as best as I could. Okay, and what you have to do is draw each figure, so draw them, and all of the lines of symmetry that it has. Okay, all of the lines, if you drew a line through the middle or through the side, that when you rotated it, or when you stuck a mirror there, that it would look exactly the same. There you go.